Okay, I am back for a medium problem. Let's check this out. I'm going to put 15 minutes on the clock. Let's go. Alright, each time Sunny and Johnny take a trip to the ice cream parlor, they pool their money to buy ice cream. How nice. On any given day, the parlor offers a line of flavors. Each flavor has a cost associated with it. Given the value of money and the cost of each flavor for T trips to the ice cream parlor, help Sunny and John choose two distinct flavors such that they spend their entire pool of money during each visit. You must print the smaller ID first. For example, if there are 5 flavors and they have the cost 2, 1, 3, 5, 6, together they have a money of 5 to spend. So they would have to purchase IDs 1 and 3, ID being 2 and 3, the associated numbers being 2 and 3, to total 5. Use one base indexing for your response specifically. Okay, what we're searching for is effectively like a complementary setup. So I think I kind of have an idea of how I would go about that. For this array of 1, 4, 5, 3, 2, and a money of 4, you need to. So any number that's greater than 4 or greater won't even be valid, right? Okay, so I can skip anything. Any value, any cost greater or equal to money, because you need to purchase 2 because there are 2 people involved. You need to get 2 ice cream cones, and they don't seem to care which flavors they are. I guess we can also assume that there will definitely be a pair that we can find. Okay, so here's my strategy. I'm going to store complements, cost complements. So I'm going to loop through costs, store the complements for check if cost is in complements. If so, done. And I can always skip money that is too much. And I think that's kind of it, actually. Should be fine. My store, I'm going to call them complements so it's really clear, equals that. Okay, loop through the cost. So for cost, I'm going to call it costs, plural, because you're an array of cost. Anyway, of cost. Naming. Okay, so skip any money that's too much. So if cost is greater than or equal to money, we're just going to continue. Const complement equals money minus cost. And, well, first we check to see if the cost is in the complements. If you are, then you're done. Then just, I guess I can't return it to console log. Or maybe I could like break. I kind of like just console logging it. And what do I console log? The numbers themselves separated by space. So I'm going to use a little fancy string interpolation, which is the money minus the cost, which is the lower one. Oh, is it? It specifically says the minimum. Okay, so min const min equals min of the cost and the money minus cost. And same thing for the maximum. Just kind of being lazy here, just max here. All right. So min space max. I think that's what you're looking for. And then if your complement is not found, then I can now store the complements here, which is complement. Okay, complements. It just needs to have a value there. So you exist, and there you go. And I don't think I need to do anything after that. Let's run some code. Probably should have just been running some code before that. Okay, so we have 1 passing, which is nice. here, oh, hold on here. So it's saying I should have found 2 and 4. Oh, because it needs to be the index. Oh, crap. Oh, you're right. The index of the cost. Okay, so slight annoyance there then. I just need to change this very slightly then. So this is going to, now I have to kind of like for loop through it. That's fine. I is less than cost.length. I plus plus, okay. And I think that should be fine. And now I have my cost equals cost I. Okay, so that doesn't change anything there. If you are one base, then what I'm actually caring about is the, not the cost, but the actual value here. So that, and the complement, which is something I actually will use, so I'm going to get the complement early. So I'm going to say cost index equals this. And then const complement index equals the complement. So they are complements of each other, so it doesn't really matter which order it's in. What matters is that we minimize them. So you get min of that. You get the min of this. I guess I'll do the same thing here. Okay, and that should do the same thing. And a complement here is actually I. I store the ith plus 1. I think that might do it. Okay, let's run this code, see what we get. Everything's wrong. Fantastic. Nans. Okay, so this cost is existing, but you do not exist. So I need to, or you may not exist. In fact, you won't exist, period. So it's just I. So actually, just to be really explicit with this. So that is the complement index, and my cost index is equal to I. Which I don't know if that will change it much, because it's still giving me nans, right? 1 and 3, so it looks like I'm off by 1. I equals 3. Oh, my I should equal, this is the problem. This needs to be plus 1. Oh my goodness. Oh, jeez. I was wondering. Run this. Come on. Come on. Come to daddy. All right. Very close. I was, yeah, it's, oh, you have to run the whole test too. But yeah, I was very close on this one as well. Okay. Took a little while. I had to, the one based index, the indexing is a little weird. So it took me a second to get that. But I think for the most part, that was a pretty good problem. Recognizing that you're using complements and then using hash map for efficiency is, I think, the key to this. Some nuance about efficiency, like skipping a cost here, and I think that's kind of the only efficiency I had squeezed out there. But yeah, that was pretty good. And that's it for me for now. I'll see you later.